We're going to talk about some of the homework problems for this week, for week 11. These are ones that you have specifically asked me about. The first one is number 3C. This is asking for all the exact solutions in this interval for this equation. In the notes for this week, there were some different strategies for solving equations like this. One of the things that you don't ever want to do is cancel things out. For example, on this one, you can see that there's a factor of cosine on each side, and it would be tempting to just cancel out the cosine of theta. But if you do that, you're actually going to cancel out some of your solutions. So we really don't want to do that. Instead of that, what we want to do is get everything on the same side so that we have a 0 on the other side. To do that, I would subtract cosine theta from each side. Now I can factor out the cosine of theta. That leaves me here with 2 cosine squared theta and here with a minus 1. Now I have two different factors, and this cosine theta that we factored out is going to give us some more solutions. That's why we didn't want to just cancel it out up here, because we would have canceled out that whole part. So what we can do is take each factor and set it equal to 0. There's one equation that we're going to solve, and here's another equation that we're going to solve. Now we're looking for the solutions in the interval from 0 to 360 degrees. That means we're looking at solutions in degrees. We want to think about where cosine is equal to 0 in this interval. Well, that would happen at 90 degrees. And it would also happen at 270 degrees. So these are two of our solutions right now. So these are two of our solutions. Now we want to go and solve this one. For this one, we're going to have to work a little bit harder. So first I'm going to solve this equation for the cosine squared of theta. That means I'm going to add 1 to both sides. Now I'm going to divide those sides by 2, and that gives me cosine squared theta equals 1/2. Now that I've got this solved for cosine squared, now I want to actually solve it for cosine. That means taking the square root on each side. That will make this just cosine. When we do that on this side, we have to do plus or minus. We have plus or minus the square root of 1/2. This one, if you simplify it a little bit, it ends up being plus or minus 1 over the square root of 2. Or if you rationalize the denominator, that would look like plus or minus the square root of 2 over 2. The whole idea is to recognize what angle this would go with. If we just think about the positive value for this, the positive value of the square root of 2 over 2, where cosine has that value in the first quadrant is at 45 degrees. So our reference angle that we can think of that's in the first quadrant is 45 degrees. Since we want this to either be positive or negative, that means that we want to find the angle in each of the 4 quadrants that would have this value. Here's our first quadrant angle, so we're going to find the angles in the second, third, and fourth quadrants. Since some of those will be negative, some will be positive, but we want all 4 of them. Here's our first quadrant angle. To get our second quadrant angle, we want to take 180 degrees minus this, which is 135. In the third quadrant, we want to do 180 plus 45. That gives us 225. And in the fourth quadrant, we're taking 360 minus 45. That gives us 315. For this one, our cosine will be the positive square root of 2 over 2. This one, it'll be negative. This one, it will be negative. And this one, it will be positive. So those are all 4 of our solutions for this part of the equation. So now altogether, we've got 6 solutions for our original equation. And I'm going to put these in order from smallest to biggest. So we have 45, then 90, then 135, 225, 270, and 315. One thing about this problem is that the answers that you got for these are slightly wrong, because in the answers it had 180 degrees instead of 270 degrees. So this really is the correct answer. In number 4C, it's asking us for all the exact solutions for the equation we solved in number 3C. This is saying all the exact solutions, not just the ones in the interval from 0 to 360 that we found up here, but all of them. So what we want to do is take each one of these that we had for our solution between 0 and 360 and think about all the angles that would be coterminal with each one of these. So we're just going to write a set where we're doing all the angles that are coterminal to each of these 6. If we're going to do the coterminal angles for each one of these, all that means is that we're going to take each one of these and add multiples of 360 degrees. We could write this as 45 degrees plus 360 degrees times n. N can be any positive or negative integer. So this gives us all of the coterminal angles. Then we would just do this for each one of these. Take each one of those answers and add 360 degrees n. Also for this one, in your answers for these problems, the answers for this one are slightly wrong because, again, it had 180 degrees in here instead of the correct answer, which is 270 degrees.